So now we're looking at question 3 here, and we want to find the area bounded. I'm just using BD for bounded. Bounded by this function here. That's a quadratic that, opens upward, positive, opens upward, and this quadratic, which opens downward, negative. So it opens downward right between x equals 3 and x equals 4. So use Wolfram Alpha or Desmos to get a graph of this, just to see which one of these functions is going to be the top of the rectangle. So I popped in the graph that I got using Desmos, and what we want to do is go between, x equals 3 and x equals 4. So 3, where's 3? 3 is probably here and 4 is here. So we're going to be looking at this region right here, and I'm going to draw in that representative rectangle. So I'll do it in red here. So between 3 and 4, here's the rectangle. And I can see now that which is the top. All right, the top. Well, the top, that's coming from the blue function, which is the negative. It's the quadratic that bends downward. That's this one here. So this turns out to be G. And the bottom of the rectangle, the bottom of the rectangle down here, well, that's coming from the red curve. Now, that's positive. So this is a parabola that opens upward. That's going to be this one here, positive. So that's the f function. So in this case, the top of the rectangle is G and the bottom one is f. So let's write this integral here. So we're going to be going between 3 and 4 of, in this case, g of x minus f of x dx. And this is a good example to illustrate why you want to draw the rectangle, because it's easy to get into the habit of always thinking, oh, f came first, that's what I'll write, f minus g. But not always, What are f and g? It's either the top and or the bottom of the rectangle. So let's do this. We're going to get the integral from 3 to 4 of g of x, which is negative x squared plus 6x minus 8. Okay, there's g. Minus f, which is x squared minus 8x plus 8, okay, dx. This is the integral from 3 to 4 of, okay, let's get rid of those parentheses, negative x squared plus 6x minus 8, and then take that minus sign through, minus x squared plus 8x minus 8 dx. Where does this put us? 3 to 4 of, okay, what have we got here now? This is negative x squared minus x squared is negative 2x squared. And then I've got 6x plus 8x is a 14x. And then I've got a minus 8 is a minus 16. All that dx. Let's integrate, so we'll get negative 2x cubed over 3. Plus, now this is 14x squared over 2. The 2 will divide into the 14 with a 7. 7x squared and minus 16x, all from 3 to 4. So let's put in the upper limit. We'll get negative 2 times 4 cubed over 3 plus 7 times 4 squared minus 16 times 4 minus, put in that lower limit, negative 2 times 3 cubed over 3 plus 7 times 3 squared minus 16 times 3 and close. Now I went to Wolfram Alpha and typed this in. You could do that on Wolfram Alpha or your calculator, and what I got here was 25 over 3. So we are saying now that the area bounded by this region right here, I'll sketch it in here in yellow. The area of that region is 25 over 3, 25 thirds square units. Now I want to end this problem with a comment here. You remember that when we did area under a curve that our function had to be continuous and non-negative. Now in this case, look what happens here. If f of x and g of x are continuous functions for which just f is above G. It doesn't say that they both have to be non-negative. It does not say that they have to be above the x-axis. If it's one's above, one's below, or if they're both below, it still works.